So for question 2, we need to find the volume before and after, and then also the percent reduction. So before and after pretty much had a similar process to do. So using the chart we're given, we have our values up here. I just rewrote them, and then the first step, we have to plug them into this equation that is given. So then we plug everything in, and then we get our value, and then we can continue to plug everything else in, and then to find for the PW, we just subtract minus 1 minus our PS, which is already given to us above. That was part of the problem statement. And then we can find our other value, and then to find our total volume beforehand, we plug the two numbers we just found in before into this equation down here, and then the 62.4 is just a known value, and then we get our volume of 516. So then after is a similar process, except when we're solving beforehand, we have to solve for the volatile fraction and the final saltiness. So for the volatile fraction, it says that 45% was destroyed, so that means that there's 55% remaining after the fact, and there was also 55% before, so we actually end up getting the same number for these two. And then you find the percentage. So you use this equation, and then to find the percentage, we use the volatile fraction number we found in the previous step, and then we find our percent of fixed solids for after digestion, because we already solved for it before. So we just do 1 minus the number we just found, and then we plugged it into this equation, which is the same equation as the before. And then we plug into the, again, this is also the same equation, and then the volume equation is the same equation as before. And we plug that in and get the volume, and then, so we have our volume after. Find the reduction percent. We use our before volume and our after volume, and that comes out as a decimal, and then you just multiply it by 100 to get a percent. So question 3, we were solving for the volume of the tank. So this problem was pretty straightforward because you're mostly just plugging in what is given to you into known equations. So this is the first equation we used up here, and we have our S value. We can solve for that, so then we can just plug everything into this equation, and basically we're finding our number of days in this equation. And then we can use that equation to further down to this equation, and oh my bad, we're not, this is the one where we're solving for our number of days, not above. Skipped ahead too far. So this one we're solving for our t, which is our time, number of days or number of hours. So I end up getting 0.662 days, which is equal to 1.49 hours. And then using T equals V over Q, we were able to find the volume of the tank. Oops. And then question 4 was also pretty straightforward, because each part we just had to plug our values into different known equations that were given to us in the notes and whatnot, and it has the same values as the previous problem, so some of the assumptions are stated above because the values are the same. So then for part A, you just plug everything into this equation to get 0.4, and then using our results from part A, we can solve for part B, and again, just plug everything into this equation. And it's important to note that we 86,400 is just a conversion factor that I multiplied out already, and that's why that's there. And then part C, again, is another known equation. I assumed an F value of 68%. That's the same value we got from our notes, because we didn't have an F given to us. So in order to solve the problem, we needed an F value, so I just assumed from the notes. And then we just plugged it in here, and as you can see, it looks like I might have wrote 63 instead of 68 when I was solving it, but that's the assumed F value I used. And that was to get our mass of O2. But it's important to note that because we're solving for the volume of air, not the volume of O2. So we found how much O2 we need, but we need to find out how much air we have to add. So these are just known values that we can assume from just science, that 23.2% of air is O2 and density of air is 1.185. So using those values, we were able to multiply by the factor in order to determine the volume of the air rather than just the volume of the O2. And that's it.